go. My name's Africa. I'm an engineering student. Doing that for a minute at college, and I've been tinkering around with random projects, 3D printing stuff, electronics, whatever, for a good minute. And I think it's about time to, start a channel and start showing some of the stuff. So most recently, I've been interested in this for quite a while. I decided to take up a bionic prosthetic hand as my current project. So I'll start showing you what I've been working on. But the idea is that it would be open source, very available, and mostly free, hopefully, and better than what's out there right now. Because right now it's, I don't know, I'll get into it. Alrighty, hey, a quick note as I'm editing this. I didn't really address the brains behind the thing, what makes it go, how the user controls it, or the actual strengths of the materials, strengths of servos, any of that. For now, let this video just serve as an introduction to the project, and if it takes any traction, takes off, on the platform, then I will go ahead and get into all the nitty-gritty. But let me leave you with this. I want it to be as fluid and just easy to use as possible. So it'll probably use some sort of electrical stimulation surface mounted reading thing. Stick it to your arm, try to pick up traces of electrical signals, potentially stick stuff on your head or neck. Again, I have no idea, I don't have any of this stuff I just invest in the future. Other thing would be use the actual hand position and rotation IMU data, right? Again, I'll get into this later. I just wanted to leave a quick note on that. Alright, so first off, I guess I just want to ask you something. Have you ever met somebody with only one arm, right? Only one hand? Most likely you have. A lot of people have. If you have, did they have a bionic cyborg arm, right? I have never seen that ever in the wild. I don't totally know why that is. I want to say most of it's that either the current tech just isn't there yet, or it's just very, very expensive. Because we got legs at this point that work great, but they're pretty passive. But hands are so dexterous, right? They need all this very active control to be useful. And I don't know, it seems like that's just not there yet. So my thought is if we make this just as cheap as possible, make it very available, very 3D printable, it becomes something that you can just make yourself, have a friend make for you, go to makerspace, school, library, whatever, they will be able to make it. So that's the current goal. So let me show you what I've been working on.
Here's an older version. I just wanted to show you what the full aesthetic version of it looks like. So it's kind of broke. These orange bits would be TPU, blue bits are PLA, these are bearings. So it allows for a pretty smooth motion, as well as soft grasping, and if you just print with the right TPU, you're going to get good grip as well. But it's compliant, right? It feels more like hand as opposed to a robot or plastic. Plus, the way these are set up is they're modular, so you can design your own. Just take them off. Maybe these ones come off because they're broke, but yeah, rip them off, and now you've got now you just have bare bones, run it with the skeleton, or make your own design. Maybe add extra grip, no grip, make them thinner, thicker, whatever you want. So let me hop back to the main model, and I've been revamping it. So I guess why I think this is potentially better than what's already on the market is because one, this is dirt cheap to print, right? But two, a lot of them are just a fixed 4 fingers that can bend straight, and that's about it. Maybe you got a little opposability in the thumb. This is designed to be very tendon driven, and it allows for a bit of, it doesn't have a slop in the joints, but it allows for bendiness and conformability. So you do have a full opposable thumb here, and I'm working on adding another finger to it. You also have a pinky. You'll notice your actual hand, it's able to, well, it can bend right down the middle. And so if you grab, say, a ball or a rounded object, having that opposability to be able to grab it seems quite important for more lifelikeliness and more dexterity. So I'm still working out all the placements here, but these are the little blue servos that everybody sees everywhere. and the way these will probably operate is that I'm gonna need to rework it, but this servo right now probably will drive both of these fingers rotation by pulling strings on it, and this top servo will probably drive these two, and this bottom servo, if we look underneath, it'll have a head that connects to this bit and that bit to cause the hand to basically fold in. I noticed, just look at my own hand, you really don't do one without the other. You often don't move your pinky in unless you're moving your thumb across, and vice versa. I'll probably have this mechanically just move about half the distance as this does, because that feels a bit more natural, as well as all the tendons I use. I'll probably use something with a bit of elasticity to allow for a good gentle grabbing. Something else I'd like to note, I am planning on probably just using a fishing line, just a high test, high weight fishing line, because it's quite cheap, like 10 bucks for a big spool of this stuff. It doesn't really stretch if you get the right stuff. That's what I'm gonna have to look for. And it's just available everywhere, right? So all these components, these bearings are just like 15 bucks off Amazon for enough to build this whole thing. Ace Hardware, you can go pick up the nuts and screws I use. The smaller screws, I got them from a kit on Amazon, but they're going to be everywhere. Assembly is pretty easy. You just scroll this stuff together. All the finger lengths are modular, as well as all the stuff in here, so you can really customize it. The idea being that you would measure the good hand you have, get the proportions correct, and then set up another hand. So right now it's all right hand based, and if it goes the way I want it, I should be able to just mirror it and have a second. I haven't finished modeling the meat on these fingers for this new model. I'm just going to make it as a skeleton first. If it works, then add meat. So I want to print this stuff before I go to bed, because it's really late. I need to go to bed. Alright, so hopping into Onshape, export the whole entire studio as individual parts, download it, extract it, whatever. Bring it all into Cura, a slicing program, and I go ahead and orient all the parts. And from here, I hit go on the slicer. Now I go to the printer, clean off the bed, and preheat the PLA so I can remove the old filament. Insert the new filament, and there it goes. Stuff's coming out. Good. That's another project. We can talk about that later. But grab the SD card reader. I've exported the print to it, and go ahead and pop in that to the printer. It's got G-code on it. That's the code the printer reads. Makes it do stuff. So we go ahead and print the full hand. This printer is nice. It shows a little preview, which is a lifesaver at times. Now we hit start, and just hope that it all goes good. I go ahead here and I turn up the nozzle temperature too manually. I probably need to change this in my slicer settings, but I just do it manually. 210 makes it flow a little better for this PLA. And there it is. Printer goes. Alright, so I am on my way to work, but I figured I'd say that I'm currently printing all the parts that I just showed you, and they're so far so good. All of them are on the build plate with no failures so far. So should have a very interesting prototype here. Print finished, and I assembled it, wired it all up. I went and picked up some fishing line, and that's currently serving as the tendons. And here we are. So because it's hard to actually get a grip on fishing line, got all the tendons wired into a handle here. So I can go ahead and pull it, and it clinches. It's very floppy because a lot of the stuff, like the fingers side to side motion, is unconstrained. So pulling this guy, there's just no control over it. But I mean, that works. Pretty happy with that.
I do have the other tendons, I think they show up here, wired for the, what do you call it, the opposite motion of the finger. So that'll let us keep them out, right? Until we pull to collapse them with the second one. I mentioned earlier, didn't print the pinky because the model was bugged out. But that will be coming. Just a quick demo on it grabbing. It takes a good bit of force to get it to grab well, but it does pick up stuff, that's encouraging to me here. Let's see, we grab this, let go. It's actually some of the better grabs I've gotten, and that's just by pulling this guy. So next steps is probably going to be build a test stand where I can hook servos up to it and try actually actuating stuff automatically for poses, whatever, and more control, because currently there's a wire on the pull motion per finger and a wire on the opposite motion, the extend motion, and trying to orchestrate those for 5 fingers with just my hands is not gonna work. So getting the servos rigged up for that, where they can hold parts rigid, is gonna be fantastic. Other thing of note, these blue servos, they almost fit in these slots, but the slot's very tight and the wire here gets in the way and prevents it from slotting in properly. So I'm gonna go ahead and resize those slots. I think these slots are probably unnecessary, and I'll be moving them to somewhere else. But I mean, there it is. There's, call it really prototype 1. I printed some fingers before and they did okay, but these ones are, they're actually working, so that's very nice. Only other thing to look at, if we really look at the finger here, you can see it's screws, bearings, and nuts. That's it. These are fairly cheap components. Fishing line was like $8. You can get all the hardware for probably around 30. So currently bill of materials is very, very low. Motor's gonna be a little more expensive. I'm gonna have to figure out how that's gonna work. These are from an older project, but I have these large servos and they're pretty strong. So I'll probably be driving it with these initially. And I might switch to a more modern approach. So instead of using a servo, use a brushless motor. That's what more advanced robotics projects are using because they allow for back drivability. That's the big one. So if this is under load, it's not the most greatest thing to be back driving it. Say its target is to go this way and I'm stopping it, right? Servos have a bunch of gearing inside. They're really small motors just with big gearing. So it can cause gears to skip or break, especially on the little blue motors. These bigger ones might be a little more resilient. So switching motors might be very beneficial. All right, so I mentioned needing to change the servo sizing. The only other thing that I really wanted to modify with this version that is in the print itself is going to be the way these finger joints are structured. So you'll notice with your hand, you can splay your fingers, moving them apart from each other, and you have good control of that, right? You can also lift your fingers back. My fingers can move back pretty far. Now, if you move your fingers back and splay, they move, they move naturally and how you'd expect, right? They continue to splay. Now, with the current joint configuration here, if you move the fingers vertical, I'll show from this angle too, and you splay, they don't splay, they actually twist, which looks very unnatural and will probably perform differently. Okay, one more time from a slightly better angle. You bring the fingers up, and if you attempt to splay, it doesn't work. They simply twist instead of splaying, which is just not what your hands do. Bring your hands back and try to splay, the splaying still happens. So to fix that, I'm gonna have to restructure the fingers. I think it's actually gonna look significantly better. So they'll look much more like knuckles. It'll make better wire routing, but essentially these bearings here, I have to rotate 90 degrees so that this folding knuckle part actually happens where it's attached to the hand, and the splaying joint is attached to the finger. So it's just gonna be a flip. That's a refactor of the 3D model.
For now, until it becomes a problem, I'm going to continue using these screws here. They are very long, but they're just what I have on hand. They don't really cause a problem here, and won't unless I really, get fine control and they start running into each other. Only other annoying thing is that there's a bunch of screws sticking out the palm quite a lot, which is kind of okay. Like the pads of your hands stick up, right? But trying to grab this flashlight, I fooled myself thinking that it was grabbing it successfully when it was really just these screws hooking it and picking it up. So you can see there the fingers are doing literally nothing. So I'm gonna change the hardware. Other than that, there it is. That is V1. Let's see if I can shake my own hand here. This is something I've been doing too, just to test, to see if the anatomy feels shaped correctly. And check that out. Boom. It's not terrible. The hand feels a bit wide, but I think that's okay. Thumb can grab across. Yeah, it works. The fingers grab pretty decent there.
Alright, well thank you for watching. Thanks for watching this far through the whole video. This is my first video I've made in eons, and this is really the first one that's of any quality. So, let me know anything you think of it. This is pretty raw. Most of it is just first take. We just threw it out there. I just wanted to get this out there, get the project, online and get some attention to it, hopefully. Like, comment, subscribe, all the YouTuber things, but really comments, I'd appreciate it. Just if you have any advice, if I'm obviously doing something very wrong, I'd really appreciate being let know. And, if any suggestions for moving forward, I'd really appreciate them. Again, I'd like for this project to become open source. I'm gonna put a little more time into it, get more of a working thing out there before I fully just drop it for everybody to see. I want it to be free. I want people to get at it and to make their own stuff. Anyways, thanks for watching, and I hope to see you in another video not too long from now.